So with degree 4, this is an even function. We decide if it's positive or negative based on the first term when it's in standard form. So this is positive. And then to determine the end behavior, we're also going to look at turning points. So add the word turning points into the fifth column. The number of turning points. We learned that the maximum number of turning points would be the degree. And then we use our graphing calculator to graph it. So we go and hit y equals. Y equals is the top left button on your graphing calculator. And then you hit 4, and then x is this button right here. It's our variable button. It has an x, a t, a theta, and an n. So hit the x, not the letter x, not the alpha x, but the one next to it with the variables. And then raise that to the power of 4. To raise it to a power of 4, you hit the caret button, and then hit 4. Press over, and then plus 6x to the third power, and then minus x. So you can see all that showing up. To graph, you go to the far right and hit graph.
That's weird.
So you can see your screen might look a little bit different than mine. And the way to make it zoom in or zoom out, you could go to Window. If you already noticed the key points of your graph, for instance, I already noticed that it was going up on both the left and the right sides. And I captured the key aspects of this graph within this window, which is -3 to 3 for the x-min and x-max. I go -3 to +3. Again, that's the window button. This is a key piece of graphing, is being able to change the window. I have a x SCL means x scale, so I made that a 1. My y min and y max are 3 and -3. So
Wait, so the y min is 3 and the maximum is -3?
no, sorry, I mixed up. -3 is the minimum.
Okay.
So the minimum has to be smaller than the maximum.
Okay. Just making sure.
Okay, so this is what we want to sketch. Notice the key points here would be the x-intercepts and the turning points and the end behavior. So I notice everything happens between -1 and 1 and +1 and 1. So I'm going to go here between -1 and -2. It looks like there's another point here at about -1/2, the origin, and then again at about 1/2. Once I kind of plot those x-intercepts, I can kind of follow that curve and go, okay, it's up here, goes down, comes back up, comes through, and it gives me some idea of my graph. I'm just doing a sketch, it's not perfect, but it gives an indication of some of those key aspects of the graph.
Hold on, I'm having trouble graphing it.
So first thing you want to do is label on your x-axis -2, -1, and +1, +2. And then notice that this graph goes through something around -1.5, something around 0.5, 0, and then positive, maybe 1/4.
Oh, because I went up to 3. I did -3, +3.
Okay,
X-axis.
but yours still probably looks the same as mine because we have the same then.
Okay.
So did you plot these points on the x-axis?
No, that's what I
Okay,
do.
so that's what you want to do first, is kind of plot those 4 points. Now the end behavior is what is happening on the far left and the far right. So on the far left, it's going up. So we're going to say up on the left. And then on the far right, it's going up as well. Up on the right. I'm going to use TP for short, for turning points. Notice it goes down and then up. That would be a turning point. It's going
Mine's kind of scrunched up, so I'm not sure.
up and then down. That'll do. There's another turning point. And then it's going down and then up. So there are 3 turning points. It doesn't surpass our degree, so we're within our limits. That's good. Next one, degree is 2. That is even, and it is negative. Graphing that in our graphing calculator. You want to pull out your graphing calculator again, practice plugging that into y equals. Negative x squared plus 2x. The negative key is down here at the very bottom. It's important you use the negative and not the minus sign. Negative 2, and then the x is right here. Make sure you're in the y equals. And then when we graph that, maybe you're already aware that that is a parabola.
How do you delete?
The delete button. right
Clear.
next to mode.
Yeah, but I don't want to clear all of it.
Oh yeah, delete's right next to mode. If you just hover over the thing you want to delete.
Okay.
So now I've got a parabola. It goes through 0 and 2 on the x-axis.
Do we hit graph after that?
Yep. Looks like we've got down on both ends, down on left, down on right. How many turning points? Just 1 on this one. Because it's going up, hits a maximum, and goes down. So that's 1 turning point.
Wait, down on left, down on right. Hold on.
See how it's going down on the left, down on the right. That's what's called our end behavior.
Okay.
Next, y equals x cubed. Try graphing that one. Notice that this is degree 3, which is odd, and it's positive. Looks a little bit like this, which is down on the left, but up on the right. Turning points. This one's tricky. Notice it keeps going up the whole time. It does curve, but it's still going up, so there are 0 turning points. Next, y equals negative x cubed plus 2x. Again, this is degree 3. It's odd, but it is negative. So we go negative x cubed plus 2x. Again, I noticed my key points here, my x-intercepts to help me graph, and then I also noted my end behaviors. So it was up on the left, down on the right. With turning points, let's see, here's 1 turning point, 2 turning points. So we can actually generalize all of this. If you notice, there's kind of a distinction here between our even functions and our odd functions and their graphs. What's something you notice?
The odd functions just like have more like turning points.
They have more turning points.
Yeah.
That actually just depends on the degree. So if you notice, our first example had 3 turning points, which is the most one. Jenna? Good point. It happened that way, but it doesn't always happen that way. The thing that we can notice is when it's an even degree, both ends are going the same direction. So they're both going up, both going down. When it's odd degree, they're going opposite directions. So we can generalize all of that in this chart right here real quick. If it's even and positive, we'll have a graph that goes both ends up. This kind of summarizes what we just did for any even function that is positive. Bless you.
Bless
Bless you.
Thanks.
you. Got any more coming or no?
Yeah.
If it's even and negative, both ends down. If it is odd and positive, it actually ends up. Okay, that's how I remember. Positive, it ends on the positive note, starts downward, ends upward. Anything could happen in between here, right? But we know that the end behavior would look like this. And then finally, if we have odd and negative, it starts up, but it ends down. It's negative. Odd and negative. So that would be
Could you go up a little bit?
up on left, down on right.
What's the other one?
Up on right, down on left. So down on left. Last thing I want to do is a quick example. You'll have a test on Friday. You get to use your notes. So
Okay.
in order to make this work alongside our project, you'll just really want to make sure you keep up with assignments, keep up with flex days, all those kinds of things. And the test should be super easy because you get to use your notes, and I'll provide you with some great examples. So example on the back, I want you to tell me about the end behavior for this function. If it says 7x to the 4th minus 6x cubed plus 10, what would be the end behavior there? Just write it on your paper on the back, and then you'll want to write the example itself and then write your answer. So if you're watching this video, this is a chart that we made that helps us keep in mind how to name a polynomial according to its degree and how to name it according to the number of terms. All right, what'd you get? What's the end behavior for this one? So even or odd? Even. Positive or negative?
Positive.
Even and positive, so it's going to be,
Both ends up.
yep, up on both ends or both ends up. Last example. If I have negative 6x cubed plus 2x squared minus 10x, what will be my end behavior.
It's gonna be odd, positive, odd, negative.
Odd, negative. So it's gonna be what?
On left.
Up on left, down on right. Awesome.